In this session, we will discuss about test for conflict serializability of a schedule using a precedence graph. In the previous session, we discussed about conflict serializability. We checked if two instructions belonging to two different instructions, if there was a conflict among those instructions or not. Now this was based on three conditions. The first condition was that the instruction should belong to two different transactions. They should be working on the same database item, and one of the operation among those two instructions must be a write operation. So based on the same lines, we will try to check if there is a conflict serializability in a schedule, but now here we will be making use of a precedence graph. So we'll go through the algorithm of precedence graph. It is quite simple. There are 5 steps. The first step is to identify the number of nodes in the schedule. Now the number of nodes will be equivalent to the number of transactions in the schedule. So if there are 3 transactions, there will be 3 nodes. Step number 2, step number 3 and step number 4 is the same as our previous algorithm. You draw an edge from node I to node J if there is a read item after a write item working on the same database item X. You again draw an edge from Ti to Tj if write item follows a read item on the same item database item X. You again add an edge to the precedence graph if a write item follows a write item on the same database item X in the precedence graph. And step number 5 says that you finally conclude that it is serializable . In this example, we are having 3 transactions, transaction T1, T2 and T3. So based upon the number of transactions, we will have those many number of nodes. So T1, T2 and T3. We'll start with the first transaction, or basically we are starting with the first instruction appearing in the first row. So the instruction is appearing with respect to transaction T1. It is a read instruction which is reading data item X. Now we'll check if this instruction is having a conflict with other instructions from transaction T2 and transaction T3. Read data item X and read data item Z. No conflict. Write data item Z, no conflict. Write data item Y, no conflict. Write data item Y, no conflict. Write data item X, there is a conflict. So we'll add a edge from T1 to T3 on data item X. T1 to T3 on data item X. Read data item X and write data item Z. No conflict. So we are done with the first instruction from transaction T1. Then we move to the next row. In the next row, we have an instruction from transaction T3, that is read data item Z. So this instruction will be compared with instructions from T2 and T1. Read Z and read Y, no conflict. Read Y, no conflict. Read Y, no conflict. Write Z, there is a conflict. So we'll add a edge from T3 to T2, T3 to T2 on data item Z. Then compare with the last instruction from T1, so no conflict. So we are done with the second instruction. Moving to the third row, we have write data item Z. Again, this instruction will be compared with all the instructions from T2 and T1. So write instruction Z and write instruction Z from T2, there is a conflict. So we'll draw an edge from T3 to T2 on data item Z. T3 to T2 on Z is already present. So we are done with this instruction also. Next we move to the next row. So this time we have an instruction from transaction T2. So this instruction will be compared with all the instructions from T1 and instruction from T3. So read and read, there is no conflict. Read and write with X, there is no conflict. Read and write X, there is no conflict. So this is also done. Next instruction is from T1, read data item Y. There is a conflict with this instruction and this instruction. So we draw an edge from T1 to T2, T1 to T2 on data item Y. We are done with this. Next, an instruction from T2. So obviously, there is no conflict with T3 and neither there is a conflict with T2. So we are done with this instruction. Next, instruction from T3. So there is a conflict between this instruction and the instruction from T1. So T3 to T1, we'll add an edge from T3 to T1, T3 to T1 on data item X. We are done with this. Next instruction is from T2. It's a write operation on data item Z. So it is not having conflict with T1. And the last instruction is write item X. So now if you look at the precedence graph, there is a cycle T1 to T3. So what does this cycle indicate? This cycle indicates that it is not conflict serializable. So if a cycle exists, then it is not conflict serializable. That means we cannot have an equivalent serial schedule for this example. We see some more examples. In example 2, we have 3 transactions. So we have 3 vertices T1, T2 and T3. We start with the first instruction in the first row, that is read data item X from transaction T1. So this will be compared with all the instruction from T2 and T3. So there is a conflict between this instruction and this instruction. So we'll draw an edge from T1 to T3, T1 to T3 on data item X. Next instruction is from T2, read data item Y. So read and read, there is no conflict, obviously no other conflicts. We take the next instruction from T3, read data item Y. So there is a conflict between this instruction and this instruction. So we'll draw an edge from T3 to T2, T3 to T2 on data item Y, and no more other conflicts. Then the next instruction is from T2, write data item Y. So here also there is no conflict. Next instruction is from T1, write data item X. So write data item X and write data item X from T3, there is a conflict. So an edge from T1 to T3 on data item X, T1 to T3 on data item X. Next instruction from T3, write data item X and read data item X. So there is a conflict. So T3 to T2 we again draw an edge. From T3 to T2 we draw an edge on data item X. That's it. So now if you look at the precedence diagram, there are no cycles over here. That means it is conflict serializable. When no cycles, then it is conflict serializable. That means we can rearrange the instructions in this schedule so that we can have a serial schedule. Now, what will be the serial schedule? How do you find the serial schedule? So what you do is you find out those nodes which do not have any incoming edge. So in this case, T1 is a node which is not having any incoming edge. So we have T1 as the first node. And the last node in this pattern would be the one which is having maximum number of incoming edges. So in this case it would be T2. The remaining edges would be in between these nodes. That is T3. So now what does this pattern indicate? This is the conflict serializable schedule. That means if we want to have a serial schedule for this particular example, then all the instructions from T1 will execute first, then the instruction from T3, and then the instruction from T2 will be executed. We'll see another example now. So in this example also we have 3 transactions, T1, T2 and 3. So we are having 3 nodes, that is T1, T2 and T3. So we start with the first instruction from T3. From the first row we have read item Y. So read item Y, is it having any conflict with instructions from T2 or T1? So this instruction is having a conflict with this instruction, and here and here. So based on this, we'll draw an edge. So read item Y with read item Y, no. Read item Y with write item Y, yes. So we draw an edge from 3 to 1. So from 3 to 1 we draw an edge on data item Y. So we are done with this. Then read item Y and read item Y, there is no conflict. Read item Y and write item Y of T2, there is a conflict. So T3 to T2 on data item Y, we draw an edge. So we are done with the first instruction over here. Now we consider the next instruction from the next row. So the next instruction is from T3, that is read item Z. So read item Z is having a conflict with none of the instructions from T1 and none of the instructions from T2. Even though we have a read item over here, read item Z, but read and read does not have any clashes. So this instruction is also done. Next instruction is from transaction T1, that is read item X. So read item X is having a conflict with read item X over here and write item X. So obviously read item X and read item X do not have any conflict. So read item X and write item X from T2 are having conflict. So we draw an edge from T1 to T2 on data item X. From T1 to T2 on data item X. So we are done with the next instruction. The following instruction is write item X. So this is having a conflict with the same instruction, that is write item X. So we draw an edge from T1 to T2 on data item X. So T1 to T2 on data item X. So this instruction is also done. Next instruction is write item Y from transaction T3. So this instruction is having a conflict with write item Y from T1 and write item Y from T2. So write item Y from T3 to T1 on Y, from T3 to T1 on Y is already there. From T3 to T2 on Y, from T3 to T2 on Y is also done. So this is also done. Next is write item Z from transaction T3. So this instruction is having in conflict with read item Z from T2. So we draw an edge from T3 to T2 on Z, from T3 to T2 on Z. So this instruction is also done. So now we are left with instructions from T1 and T2. So the next instruction is from transaction T2, read item Z. Read item Z is not having any conflict with T1. So this instruction is also done. Next is read item Y. So read item Y is having a conflict with write item Y. So we draw an edge from T1 to T2, T1 to T2 on data item Y. Next instruction is from T1, write item Y is having a conflict with write item Y from T2. So an edge from T1 to T2 on Y. T1 to T2 on Y is already. So now no more instructions to be compared. So we are left with only instructions from T2 which cannot be compared with any other instruction, neither from T1 nor from T3. So this is our precedence graph. So if you look at this particular graph, there are no cycle. That means this graph is conflict serializable. So now your job is to find out what will be the equivalent serial schedule. So you pick up that node which is not having any incoming edges. So the first node in this case would be node T3, and the last node in this pattern would be a node with the maximum number of incoming edges. So that would be T2. And all the remaining nodes between T3 and T2. So T1 followed by T2. So this would be the serial pattern. So if you want to find the serial pattern, it will be all the instructions from transaction T3 executing first, followed by T1 and then followed by T2. So if you have observed carefully, when we were comparing instructions, we were moving from top to bottom. So one instruction, we were comparing it with the other instructions below it. So this is how we check for conflict serializability using a precedence graph.